So after our break and last week working on our project, and then of course me being absent, being sick, we need to get back to this first standard in geometry, which is all to do with finding area. And it's finding area of simple and composite figures. And what I mean by simple, a simple figure is just a normal rectangle or a normal trapezoid or a triangle or whatever. Composite means a lot of them that are stuck together. Or it could be a trapezoid with a rectangle removed from it. This type of thing. This is the idea of composite. It's shapes that are combined or shapes that are one is removed from another. So we're going to have a look at some examples of this. So this is level 2. And in this case, level 2 is just basic shapes finding their area. Alright, so we'll go through these examples really quickly. First thing we're talking about is rectangles, and the area of a rectangle is length times width. Okay? So I'm not going to necessarily find the answers for you. You can just plug them into a calculator or multiply them out yourself. So if you look at number 1, the area is going to be 10.6 times 14.7. Plug that in your calculator, that's going to give you the answer. The second one, the area is going to be 3.2 times 7.4. Alright, plug it in, get your answer. It's going to be inches squared is going to be your unit of measure for that. And then the last one, the area is equal to 5.6 times 4.9. Alright, we're just multiplying length by width. So it's very straightforward, very easy. So after that, we're going to have a quick look at some parallelograms. How do parallelograms work? Well, again, a parallelogram is length times width as well, so I'll write that down here in red so we can see it. So for parallelograms, area equals length, or actually what we say for that, we say base times height. Okay, and I'm going to erase that B because sometimes people think it looks like a 6. Base times height. So, the key thing for a parallelogram, what you look for is the 90-degree symbol, which is this thing here. There's 2 lines that touch off that. There's this one and there's this one. Okay? That 12 is the height because it connects one side of the parallelogram across to the other. Okay? At 90 degrees. And then the other one we would consider to be the base. Okay? It doesn't necessarily have to be going vertically to be the height. So on this one we have the base is 16.8. The height is 12, so the area is 12 times 16.8. Okay, and you're going to get your answer in feet squared in that case. Again here, look at the 90-degree symbol. As before, the 2 lines that come off it, well, there's an 8.3 and a 4.4. They're the ones you multiply. Okay, area equals 8.3 times 4.4. Alright? And yeah, the height is the 4.4 because it goes from one side to the other. It goes from the side that the 8.3 is on. Now it's when the side is extended, but that's how it works. And then the last one here, we have the 16.3 and the 11.7. Okay, so just plug them into a calculator or just multiply them out. We know how to multiply, and that will give you the answer. Okay, that's parallelograms. Let's have a quick look at trapezoids, right? So at the top, the formula for trapezoids, area equals base 1 plus base 2. You add them up, you multiply by height, you divide by 2. And the reason we do that, if we stick 2 trapezoids together, it becomes flip one upside down and jam it onto the end of the other one. It makes a parallelogram. Okay? And then when we find the area of the parallelogram, we divide it by 2. So in this case, I'm not going to actually solve it. You can work it out yourself. So the area equals base 1 and base 2. So remember, the bases are the parallel sides. So this is parallel to this. So it's going to be 12 plus 8 times 7 divided by 2. This one here, 8 and 13. So 8 plus 13 times 10 divided by 2. I'm not going to do the last one, you can do it yourself, but in this case 8 is the height. Triangles then, simple. The area of a triangle is the base times the height. So if you look with triangles again, look for the 90-degree symbol. See that? What two sides touch at the 90-degree symbol, or what two lengths touch? 2 and the 3. So that's the base times the height. And you have to multiply the two of them. 2 times 3 divided by 2. Again, look at this one, 90-degree symbol. Connects the 4 and the 3. Area equals 4 times 3 divided by 2. I'm just going to erase that and tidy it up in here. You'll see there that on that one, the 5 is there, but the 5 doesn't represent base or height. Okay, so it's not necessarily needed in the formula. And then the last one, look, if there's the right triangle, the right angle symbol between the 5 and the 8, connecting the 5 and the 8, 5 times 8 divided by 2. Okay, plug them into your calculators or just work them out, they're very easy. Okay, and now the last one. So what you're going to look at here, we have Mr. Smith's flower garden is 36 square yards in area. That's the area, 36 square yards. Select all figures that could represent Mr. Smith's garden. So for one of these three Mr. Smith's garden, it has to be 36 square meters, or 36 square yards. So whatever ones have 36 square yards as their area, they're the ones. So look at the first one, the triangle. The area of this triangle, well, we don't have a right angle symbol, but it's clear that that's where it is. It's going to be 6 times 6 over 2, 18. So the first one, the area of the first is 18, it's not 36, so that can't be Mr. Smith's garden. Second one, 6 times 6 is 36, so yes, it could be this. Come down here, we're going to do 7 plus 5, because it's a trapezoid, so you add the perpendicular sides, or the parallel sides, times 6 over 2. 7 and 5 is 12 times 6. Yes, that's 36. So it could be that. And the last one is 6 times 5, which equals 30. So it couldn't be that. Okay, so these two shapes here have area of 36, so they could possibly be Mr. Smith's flower garden, because his flower garden has area 36. And that's it.